Okay, so now we're going to start doing some of our chemical tests. The first one that we're going to do is dissolved oxygen. And so this is measuring the oxygen in our water. So just like we need air to breathe, so do our aquatic species. So it's important for us to note what the dissolved oxygen is. And a reminder, when you are about to begin sampling, that you put on your safety glasses and you have on gloves as well. And so for the dissolved oxygen test, the first thing that we want to do is with any of our tests is that we always want to rinse our sample bottle or whatever we're collecting in 3 times, and we're always collecting our sample facing upstream. So we're collecting what's coming downstream to us. And so for this sample bottle, this is a glass bottle, and so we want to acclimate this glass bottle to the water temperature, because dissolved oxygen and water temperature play off of each other. Colder water tends to hold more dissolved oxygen, warmer water tends to hold less. And so you'll notice for this glass bottle, when you get it, you're going to see there's a piece of paper towel in it. It has nothing to do with the testing process. It's only part of the cleaning process to ensure these two parts don't stick together. So when you're done sampling with the dissolved oxygen, just make sure you stick that paper towel back in. So again, I'm going to rinse 3 times before I collect my actual sample. This is just to ensure the integrity of the water quality sample that I'm collecting. And so for sometimes with streams that have a silty bottom, you're going to stir up some of that sediment when you get in. So you want to give it a few seconds for it to settle back down, and then collect your sample. And for this one's a little bit different. Again, we're going to rinse 3 times, and for this one we're going to let it sit for 2 minutes, dump it out, and then do an additional 2 minutes in the water before we actually collect our sample. Again, that's just to get this glass bottle to around the same temperature as our water. And so some tricks for doing that is you can hold the water sample with your hands and kind of bending over. If the stream is shallow enough and you have boots, you can stick that sample bottle between your boots and just hang out for that 2 minutes. Then we also have tongs that you can use, but just request those. We don't put those in all of the test kits. So I'm going to first do my rinsing 3 times. Let that sediment settle back down. Okay. 1, 2, 3. And you can just hold on to the stopper, and this time I'm actually going to place the sample bottle between my boots. And just let it hang out for 2 minutes. So now that the first 2 minutes is complete, we're going to lift the water sample bottle up and dump it out, and then place it again for an additional 2 minutes. I'm going to dump the sample out and then place the bottle again between my boots. Get it nice and set. Okay. And then time for an additional 2 minutes. Alright, so now that our sample bottle has set for the additional 2 minutes, we're actually going to collect our sample now. And this is really important since we only are collecting the dissolved oxygen. We don't want to get any introduced air bubbles. Sometimes in these shallow streams, it's easy to get like an air bubble in there. So what you want to do is, to the best of your ability, tilt that sample bottle up and let that air bubble escape. And then another trick is to cap the bottle underneath the stream surface, or when you bring that bottle up, make sure that it's overflowing. That's another way to ensure that you get no air bubbles in there. So I'm going to lift the sample up. I'm going to let an air bubble escape. So I have overflowing water in here, I'm going to put my stopper. Okay, and so you're going to see that it's a pretty clear looking sample so far, but we first, of course, we're going to need to do some testing to determine the dissolved oxygen. So at this point, you can bring the sample back to the stream bank to your test kit. And this is where you then work with your reagents to produce that chemical change in your sample. And so what you're looking for is our reagent packets. They are labeled 1 and 2 and 3. Right now we just care about reagents 1 and 2. So I've already pulled those out. They are very similar looking, but they do have numbers on them. So what we want to do is we're going to put reagent number 1 and number 2 in. You don't need to mix in between those. I'm going to get my trash bag ready to collect that packet when I'm done with it. It's a good thing to kind of flick the bottom of the reagent packet, make sure that reagent is down at the bottom so you don't lose it when you're cutting. I'm going to open up my sample here. Do number 1. Always put in number 1 first. Sometimes if you put in number 2, you're going to get a weird result, but it should be easy to remember to do number 1 first. If you're wondering the reagents that are going in here, a lot of the reagents that we're using are like sulfonic acid or a sodium to kind of produce that chemical change in binding to the properties of our sample. I'm going to then put in number 2. And I want to ensure that you got all of the sample out of there. I'll double check my 1 to be sure. Okay. All my trash taken care of. And then this is the point where you want to look at your sample bottle and see if you're going to get an air bubble when you put the sample, the top in. So you want to ensure that there's no air bubbles. And so one trick that you can do is that extra dropper that's hanging out in your kind of small Tupperware container. You can grab a little bit of the some extra water from the creek. I'm going to rinse this first 3 times just to make sure that it's good. And this won't affect the temperature too much or the test, so it's safe to do. And some of the reagent is going to be stuck to the side. That's okay. It's going to get mixed up when you start doing your mixing. And so what you're going to want to do is you're going to put the cap in kind of fast to ensure that there's no air bubbles trapped. And you're going to notice that there's going to be a flocculant or precipitate that's going to form. That's just the chemicals kind of doing their process. And I did notice I did get a little bit of debris in here. It's really important to try to avoid doing that, even with me kind of making sure that I was collecting with the sediment was down. Sometimes it's hard to totally ensure that. But it shouldn't affect the test too much. And what I like to do is I like to do this inversion method with doing our mixing, for at least for the dissolved oxygen. It ensures kind of a good mixing without creating air bubbles in the process. Some of the reagent will be stuck to the bottom. That's normal. It'll get dissolved the farther in the protocol that we get. So I just mix this for about maybe like 50 inversions altogether. I just want to make sure that all that sample is mixed up to the best that you can. And then what you're going to want to do is let this bottle sit. You're going to let that flocculant settle below this white line that's on the sample bottle. And then you're going to let it settle down, wait until it's settled, and then you're going to mix it again. This is just to ensure proper mixing of our chemical reagents. And all of these protocols, all of these steps that I'm talking about are in that kit binder that I mentioned at the beginning. So especially when you're going out for your first few times of monitoring, it's really important to refer to that manual to make sure you're doing all of the proper steps. It's easy to forget them in the process, so always refer to that kit binder. Okay, I would say that this is properly mixed, and I'm just going to let this hang out in my kit and let that flocculant settle below that white line. Okay, so now that our flocculant has settled down again, this is the point where we're going to add in our third reagent, which looks different than our first two. It's more in a pillow packet. We'll still use the scissors to open this. Just know that that top end might fly off. Just try to pick it up the best that you can. I'm going to remove my stopper here. Okay. Put my reagent in. Don't worry about it getting stuck to the side. That's okay. It'll still mix up. Okay. Got my plastic piece. My trash. And I notice I'm a little bit low on water, so I'm going to use my stopper again and get some water from our sample creek here. Just to ensure that we have no air bubbles. I'm going to add a little bit more. And actually when the third reagent is put in, that actually sets the DO, so it shouldn't change at this point, but just to be sure, we don't try to not have any air bubbles in here. Okay, I'm going to add just one more stopper full. One more dropper full here. Okay, should be good. So I'm going to cap again and then do my inversions. So some of that extra water will spill out, that's okay. And at this point you're going to notice that that flocculant is going to disappear and you have like a yellow color, like a clear yellow color in here. And that crystals from the reagent number 3 are going to dissolve. So you want to just do inversions until those crystals dissolve. And again, try to remember to do inversions versus shaking up and down. Reduces your chance of getting air bubbles. We're almost there. During these waiting times, this is a time to notice your surroundings, if you see any native or invasive vegetation. So around us here I do see sword fern, which is native. I see salmonberry, which is native, and cedar, and alder trees. But I do see bindweed and Himalayan blackberry, which are invasive. So those are things that you can make note of. Okay, so I would say that is good for mixing after DO number 3 is put in. So at this point you just have a clear yellow color. And now we're going to move into our titration process, which is going to help us determine our level of milligrams per liter for our dissolved oxygen. If you think back to high school chemistry, titration is just a process to dilute a substance down to find the amount that you are measuring. And for us, it's in milligrams per liter. So this is when we move to our other kind of sample equipment that we have here. And so what we have is a square mixing bottle and a measuring tube. And so we're going to pour a tube full of our original sample all the way to the top. Don't worry about spilling. We're going to pour that tube full into our square mixing bottle. And then you also want to make sure that you do another sample. So you have 2 tubefuls. If you do one, you're going to get some weird numbers all the way to the top. Okay. Really important, you want to cap your original sample. That way if something goes wrong for the rest of the process, that you still have that original sample that you can start with. You don't need to start all over again with collecting originally from the creek. And so all we care about right now is our square mixing bottle, and this is where we're going to start the titration process. And what we're going to do is use sodium thiosulfate, and that's going to dilute down our sample to almost looking like drinking water or clear. And we're going to count the number of drops it takes to make that sample clear. And that's going to help us determine the milligrams per liter that we are looking at for our dissolved oxygen. So really important when you're doing any kind of drops that you hold the dropper perpendicular to the ground to get a more uniform drop. Try to avoid holding it off to the side like that. And you're also going to want to do a drop, swirl, drop, swirl. Try to avoid putting in 10 drops and then swirling. This will give you a different number. So this reagent works best with active motion, so making sure you are swirling in between each drop. And we're going to count the number of drops that we put in. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, get some more. Give my knees a break there. 10, 11, 12, 13, 14, 15, 16, still have a yellow tinge, 17, 18, 19, 20. And at this point, when you are starting to get pretty clear, it's helpful to hold the sample, so I have 20 drops, against a white background and see if you notice any kind of yellow tinge. And I still see a little bit of a yellow tinge, so I'm going to put another drop in, see if that makes a difference. So this is 21. I think that improved it. Okay. Put does look better. I'm going to put one more in, see if it makes a difference. If not, then we know that we were good at 21. So this is 22. Okay, I would say that is the same as 21. So we don't record 21 down, but we divide 21 by 2, and that gives us our milligrams per liter, and that's what we're going to record on our data sheet. So 21 divided by 2 is 10.5 milligrams per liter. And for our state standard that we're looking at here for the creek, we should be greater than or equal to 9.5 milligrams per liter. So we're hitting that standard for that. And so, so we're all done with our sample. So we know that we're good, and this is a good time when we can dump it out. So like I was saying before, we always want to dump our remaining sample when we're done testing into our waste container. That way we dispose of it back at our lab. So for the dissolved oxygen, I'm going to dump what was in our square mixing bottle. I'm also going to dump our original sample since we know we are happy with our result. Everything went well. So now that we're done with our dumping of our sample, we are going to just close our container, and then we're going to close up our kit. And so get all of our tubes back together. Really important to put the paper towel back between the stopper and the glass bottle, just to ensure those two don't get stuck together. I'm going to ensure that my liquid reagent is nice and tight, and then close. This is a good way to, before you move on to the next test, to ensure you aren't mixing up sample bottles and reagents.